The physical principles of laser cleaning. 1. The laser beam is absorbed by the surface contaminants. This absorption process converts the laser energy into heat, causing the contaminants to rapidly heat up. 2. The absorbed energy results in the formation of a rapidly expanding plasma, a highly ionized unstable gas. This plasma generates a shockwave as it expands. 3. The shockwave produced by the plasma causes the contaminants to fragment and be removed from the surface. The force of the shockwave is sufficient to dislodge the contaminants, effectively cleaning the surface. The advantages of laser cleaning, particularly with high pulse energy and short pulse width, are significant when dealing with high reflectivity materials. It can be effectively applied to scenarios such as removing coatings, residual electrolytes, and adhesives from workpieces, as well as surface texturing, polishing, hydrophilic and hydrophobic modification, and pre-welding treatment. The precision and non-contact nature of laser cleaning make it an ideal choice for these applications, ensuring efficient and effective surface treatment without damaging the underlying material.